Hey there! Today, we're going on a bit of a medical detective journey into asthma. Our mission to uncover a pretty surprising link between some of the most common germs out there and this chronic lung condition. So let's just dive right in. When we think about asthma, our minds usually go straight to things like pollen or dust mites, or maybe whether it runs in the family. But what if there's another major player in the game? A kind of hidden instigator that we've been overlooking all this time. Well, the central idea we're going to unpack today is that certain microbes, we're talking bacteria and viruses, don't just make you feel sick for a few days. They can actually play a huge role in causing, triggering, and making asthma worse by setting up this chronic inflammation deep inside the lungs. Okay, let's officially start our investigation. We are on the hunt for the culprits behind a huge chunk of asthma cases, and the evidence trail starts with a number that is, frankly, pretty staggering. Yeah, look at that, 47%. This is our first big clue. A massive study discovered that one specific bacterium could be linked to almost half of all chronic asthma cases. Let me say that again, nearly half. This isn't just some minor connection. This is the prime lead in our whole investigation. But, before we can start profiling our suspects, we really need to understand the crime scene. And it turns out asthma isn't just one single thing. It mainly comes in two different forms, and our microbial culprits, well, they definitely have a favorite. So on one hand, you have atopic asthma. This is the classic type you've probably heard of, the one tied to allergies and genetics. But our focus today is on the other kind, non-atopic asthma. This one often shows up in adulthood, you don't inherit it, and it can be a lot more severe. And most importantly for us, it has this really strong connection to chronic infections. This right here is our crime scene. All right, let's bring in our first suspect. It's a bacterium called Chlamydia pneumoniae. Now, this is not the same chlamydia you might be thinking of. This one's an airborne pathogen that goes after the respiratory system, and it is a master of disguise, incredible at hiding in plain sight. So here's the mugshot. Chlamydia pneumoniae is what scientists call an obligate intracellular bacterium. And that word obligate is key. It means it has to live inside our own cells. It's basically a parasite that hijacks our cellular machinery because it can't even make its own energy, its own ATP. And that's exactly what makes it so sneaky and so persistent. And its method of operation, its MO, is just brilliant. It has this two-stage life cycle. It gets into our body as this tough little spore-like thing called an elementary body. Once it's safely inside one of our cells, it changes form into something called a reticulate body and just starts making copies of itself. Then, all those new copies turn back into elementary bodies, burst out of the cell, and go off to infect more cells. It's this vicious little cycle that lets it set up a chronic low-level infection that our immune system has a really hard time getting rid of. So how does that cause asthma? Well, even when it's hiding inside our cells, it's constantly releasing these stress proteins. Think of it like a faulty fire alarm that just will not shut off. This constant alarm signal from the bacteria makes our own immune system go into overdrive, triggering this nonstop inflammation that over time leads to the very tissue damage and scarring that defines severe asthma. Okay, let's move on to suspect number 2, Mycoplasma pneumoniae. This bacterium has a completely different playbook, but it is just as effective at causing damage. Take a look at this one's profile. The most important thing to know about Mycoplasma pneumoniae is what it's missing. It doesn't have a cell wall. And that's actually a brilliant defense mechanism because a lot of our go-to antibiotics, like penicillin, work by attacking those cell walls. Without one, this microbe is naturally resistant. And instead of hiding inside ourselves, it just camps out right on their surface. Its method is less like a stealth operation and more like a direct chemical assault. First, it uses these special proteins to latch right onto the cells that line our airways. Then, it starts spewing out this toxic cocktail of hydrogen peroxide and other nasty chemicals that directly injure and kill those cells. All that damage, in turn, kicks off a huge inflammatory response, creating that classic airway hyperresponsiveness we see in asthma. And the evidence against this one? Oh, it is just stacked. It's involved in triggering asthma attacks in up to half of all cases. It nudges the immune system towards a more allergic-style response. It damages the airway lining, which exposes sensitive nerve endings, and it even prods our mast cells into releasing histamine, a key chemical that makes airways clamp down. It's really a multi-pronged attack. All right, on to our final suspect. This one isn't a long-term instigator like the bacteria we've been talking about. Instead, you should think of this one as a powerful accomplice, a trigger that kicks off acute attacks with terrifying frequency. And you absolutely know this one. We are talking about the human rhinovirus, or HRV. You probably know it as the main cause of the common cold. It's a familiar foe for sure, but its role in asthma is way more serious. Just look at this chart to see how much of a problem it is. In kids who have asthma, a whopping 80 to 85% of wheezing attacks are linked to viral infections, and rhinovirus is the #1 culprit. So while the bacteria might be setting up this smoldering fire in the background, it's often the common cold that comes along and just throws gasoline all over it. So its role is crystal clear. It's an acute trigger. When you get infected, it causes your airway cells to release this flood of inflammatory signals, and that's what causes the immediate airway tightening, the swelling, and the mucus that define an asthma attack. And what's really interesting is that it's so potent, it can even ramp up airway reactivity in people who just have allergies but don't even have asthma. So after going through all the evidence, it's time to deliver the verdict. It's become really clear that these tiny culprits play very distinct but deeply interconnected roles in the complicated story of asthma. So here's our final lineup. First up, we have C. pneumonia, the persistent instigator, the one creating all that underlying long-term inflammation. Then we have M. pneumonia, the chronic irritant, which directly damages the airway cells. And finally, we have the human rhinovirus, acting as the acute accomplice, the one that comes in and triggers the vast majority of those sudden attacks. And all of this brings us to one last, really provocative thought. If a huge number of asthma cases are actually driven by these microbial culprits, what does that mean for how we treat it? This whole understanding cracks open the door to a radical new idea that maybe, just maybe, targeting these infections directly with things like antibiotics or antivirals could one day become a frontline treatment for asthma itself. Pretty wild to think about, right?